I think we are in a good position to start. Vaibhav, should we start?
Yeah, Sudeep, let's start. Meanwhile, others can join if they're coming.
Okay.
Thank you.
So, welcome everyone. Thank you for joining this meeting or for this particular session to understand what is Agile performance testing, how we can leverage it, how it can be used, and how we can take benefits of this particular approach in our service and in our day-to-day deliveries. So, starting with, there are few key questions on what needs to be done first. So first is why don't the traditional performance testing models fit nicely with Agile? So that we need to look into. What needs to change? How do we make those changes? This we need to look into. Because why we are doing all these changes? Because more and more delivery, more and more quality is being delivered through Agile mode of software delivery. And finally, we want to give that over the internet performance is nothing but the how good your service is, that is the quality of your service, finally which leads to a higher revenue. So these are few questions like why we need to move from traditional methods to Agile, and especially what is there for performance in this. What needs to change? What all we have been doing traditionally, does it hold good as of now, or do we need to change the approach for it? And finally, how do we make those changes? How do we make it happen in the real world? So this is actually, if I go to the next slide, you can see performance in the waterfall model. Like this is what is being done for most of the scenarios or for most of the cases, where we have a plan, when we do a design, we build the software, we test it with system integration, UAT, user acceptance tests, and just before deploying it in production, there is a small scope or there is a small area for performance testing what we keep. And the problem with this particular approach is, as you can see, like it's very late in the SDLC. So whatever has been planned, whatever has been designed or built, that actually is tested at a very late phase in the performance testing or in the software delivery cycle. So any bottlenecks or any issues corresponding to design, planning, or even the actual code base goes for a toss, and one can't actually fix it in that particular for that particular sprint or to that particular model. And as you can see, like it's a one-way communication of the results, and ultimately it leads to a big failure. So this is what the waterfall model nowadays does, or the waterfall model has been doing. What can be done is, like going before that, like there are like to implement the performance testing in each of the phases of the software development life cycle, and how we can cater it. So before that, like I've just kept an overview on Scrum. Like it's one of the most famous agile methodologies, Scrum. There are other methodologies like Kanban and XP. But since it's very famous, like I've tried to keep a brief overview for people who are not aware of what Scrum is, how it can be used. So there is like a product backlog which is maintained by a product owner, and there is they have few stories. So you can see like there is a create account, book reservation, print report, logins, stories which are being discussed by with the business. The product owner does that particular work, and based on those stories and based on the prioritization, a sprint backlog is created. So when we talk about what is a sprint, So as you can see, the definition what I've mentioned there is a that it encourages teams, or Scrum is a project management framework that encourages teams to self-organize and deliver the functionality iteratively in a 2-week time boxes called sprints. Why 2 weeks? Because it gives a very optimum way of delivering. A very important term here is a potentially shippable product increment. So 2 weeks is a good amount of time to create a potentially shippable product increment. And so whatever the time box we are having, so normally the time boxes range from 2 weeks to 4 weeks. So whatever the time box you have, during that time box, you need to plan, you need to write the code, you need to test it, you need to do the performance test. So all in all, like, there is no room for performance testing based on a very, very small timeline. So how do you fit in this particular scenario, or in Agile, the performance testing? That is what we are trying to see here. So what needs to be done is, if we go next, if we see how do we give an attempt for Agile performance testing, we have different sprints. So we have a sprint 1, sprint 2, sprint 3, and so on till sprint n. And we do the performance testing for each and every sprint based on some criteria, some methods, like how it needs to be done. Obviously, that we will surely discuss in the coming slides. Eventually, we deploy that particular application into production, because the application has been tested iteratively for different sprints over different amount of time. There is a room for change up to a certain window when you go or when you do Agile. So if I show you this particular slide, if you see here, the SDLC is actually nothing but a sequential list of activities. So we do analysis, design, code, and test, and as and when my time increases, each block of my work starts coming in. But in Agile, all the 4 activities start simultaneously. So we start with the analysis, design, code, and test all at the same time. And more importantly, as I said before, the performance of an application is very much dependent on the design, and hence it should be really addressed in the initial phases of the design and in the analysis phase. So ideally, it is where, like, when we talk about a particular term, that is the performance engineering. So the performance engineering comes into this picture where we actually do the performance analysis, or creating an application more from enhancing the performance of that particular system. So we do the analysis on that particular module. Then the design is made in such a way that it performs, or it gives a highly performing application. Thereafter, the code is written in such a way that the application itself gives a high performance, rather than waiting last to check whether the application or the performance is proper or not. The idea is to write code in such a manner in which your application performs optimally, and finally you test it. So how do we do this? Because ultimately the main goal of the main objective for doing all this is that rather than doing a late cycle of performance testing, we want to shift left, that is towards the analysis and the design phase, start capturing the performance metrics from those phases itself, and start creating a product or an application which is high performing. So we do a early cycle of performance analysis, or any ongoing performance analysis. This is a very important phase, like in terms of how this shift left can be done. Initially, it's not that easy to do that, because we have been following more of our activities traditionally. But still, like if we follow it, if we try to follow it on a day-to-day basis, then surely we should be in a position to give high-performing applications with reduced risks and a very high efficiency. So these are like few of the points why we want to shift left, and what is the focus in shifting left, that is during the analysis and design phases. So now we are actually coming into some criterias, like where we have to incorporate the performance requirements in the design phases itself or in the analysis phase itself. So if you like most of you might be aware of what a user story is. So say a user story has been given, like as a dealer I want to create a product configuration for an order so that my customer can purchase the equipment they need. That particular user story needs to be specifically broken down just to capture the performance requirements. So say for example, all steps in the product configuration process will have a response time of less than 2 seconds. And what if like 1500 dealers are concurrently using the system to configure the products for customer orders? So overall, like these sort of breaking or breaking the user story into smaller components or smaller tasks need to be done, so that we know like what sort of testing with respect to performance needs to be done at that particular component or that particular unit level. So now a technical story could come up like, as a dealer, I want the response time of any step in the product configuration to be less than 2 seconds. There could be some constraints also which could be added to that particular user story. So where you want the system to respond in around 2 seconds with a maximum 1500 user concurrency, which while ordering that particular or having that particular purchase. So the step would be for the first step in any agile performance testing activity would be to break down the user stories into reasonable performance specific metrics that can be captured, that can be tested in each of the phases going forward. Okay. Moving ahead. Okay, so what do we want to do by doing performance testing in Agile? We want to create a performance testing culture not only for the performance testing team but across the organization, where each and every individual, starting from the developers, the system architects, the testers, even the end users or people who are giving production support, they all are focused for delivering or giving a high performance environment or a high performance application. So how do you do that? As I mentioned, you capture the non-functional requirements, you make performance everyone's job. So it's not only the job of a performance tester to test or to see what the performance is of that particular application. It's everyone's job, because collaboratively, collectively, only high-performing applications can be delivered. So a role has to be created in order to coordinate the performance activities, and moreover, like in a COE, like the performance COE what we have, test architects need to be available who can become mentors in guiding like what needs to be done starting from the analysis or the design phase, so as to create high performing applications. Okay. Now we actually come down to the ways in which a performance testing in Agile needs to be carried out. So if you see here, the way is to incorporate the performance testing or the analysis into each and every sprint. Now, sprint, as I mentioned, if you remember, like it was a time box period. So optimum duration was 2 weeks, starting with 2 weeks to maximum 4 weeks. And what all types of testing what you do here? So one is a unit level performance testing, one is a component level performance testing, and you club all these activities with a CI chain. Most of you are aware of we have a lot many continuous integration tools, Jenkins, Bamboo, TeamCity, and most of the performance testing tools, Load Runner, JMeter, they can very well interact with these CI servers or with these CI tools. So the integration or the usage of this particular these particular tools with the CI servers is highly important, and that is what makes a high performing application. Because truly speaking, like I've used this in one of my previous projects, and it really looks bad when the developer's build gets failed because of application performance. So whether it's at a unit level or a component level, it really feels bad to the developer that why that component started failing or why that unit level performance was not meeting the SLA. So these are few areas or these are few points which can be taken up or should be taken up to deliver projects in Agile, and that too from a performance testing perspective. Okay, sorry. Yeah, I'll move ahead. Any questions till now? Because we have like I've discussed a lot many points in a very short duration of time. Any questions from anyone? Okay, I guess no. So how do you do a unit level tuning or a unit level performance testing? So as you can see, like I'll try to go through the graphs or through the flowchart on the left hand side. So if you see, say a piece of code is developed, a unit testing is done, you carry out a unit level performance testing on it. So how do you carry out a unit level performance testing? So these are few activities which are mentioned here. You identify the methods, you create the scripts for those particular methods to invoke the individual command, and finally you test those particular methods or those particular individual methods under normal load and see how your CPU or memory is getting utilized. If they are more or less in under acceptable range, you pass it or you pass the unit level performance test to component level. So similarly, as in the flowchart, as you can see, if you have done the unit testing or the developer has carried out the unit testing for the piece of code, a unit level performance testing is done. How you can carry out unit level performance testing? There are few frameworks available. I've mentioned those frameworks already in this particular deck that we will discuss in the forthcoming slides. So you carry out a unit level performance testing. If at all you find any performance issue or a performance bug, you do further code optimizations, and this cycle goes on and on unless and until your unit level performance is proper or not, is correct or not, or it meets your SLA. If no performance bug is found, then you actually pass it on to the component level performance testing. So what does a component level performance testing do? Let me go next.
Hi, Sudeep.
Yeah.
Yeah, sorry, Prabhakar here. I have a question here.
Yeah.
Okay, so by doing the performance testing in the Agile methodology, and you want to do unit level performance testing, so does it mean that you want to cover all the flows which is being developed for the application?
It's not the flows actually. It's more than a flow. It's coming to a method level or a function level. So maybe a particular flow can have 10 methods. So you need to test each and every method. That is what I'm talking about here.
Okay,
So,
but see, the test cases will be different for unit, I mean manual testing as well and performance testing. So
right.
how we can cover these test cases, and we will not get SLAs in terms of method level or function levels usually.
No, ideally there are not SLAs, but still you will have few areas. Say for example, a banking transaction. A banking transaction should happen. If I give an example, a banking transaction should happen say within 5 seconds. And if there is an associated code or an associated method with it, so that method has to be first tested before it goes for an integration with other components.
Okay, so what I feel is that you want to do 100% coverage of all the methods and functionalities developed, and does it actually
Right,
increase the cost of performance testing? I mean the efforts.
which are performance centric, not all. Because out of all the functional scenarios or from all the manual test cases, whatever you have, you never or you hardly do all the executions or all the performance tests for all the scenarios. You never do that. You always carry out performance tests only for business critical transactions. So only for those business critical transactions at a unit level, at a code level, or specifically at a method level, how those are behaving. And very important is, this is just when the development is going on. So side by side, when the development is going on for that particular method, you actually test it. Okay. And see what the response or how that particular method is behaving or performing.
Okay, so I mean, if we are going to cover the critical functionalities or scenarios, well, fine. But let's say if the development team is involved in developing some non-critical scenarios,
right?
So that time it would go into an idle mode, right? So engaging that much early.
No, that is why we are talking agile. And if you see here, like if I go back to this particular slide, so it is like analysis, design. If you see this particular area, analysis, design, code, and test, all happen simultaneously. So there could be, like, for a certain sprint, you have 10 user stories which needs to be delivered. Out of those 10 user stories, few user stories which are critical for application performance that you have identified. So already the analysis or the design phase has already started for those user stories. So ideally you can do a unit level performance testing there. Did I clear your doubt?
Yeah, my concern is actually when there is a development starting along with the testing, we are actually putting into a wait stage. I mean, I'm also working in a project right now which is following Agile performance testing. So the development and
so that is what I'm saying. That is what I'm saying. So it is a highly collaborative approach. So it cannot be like only the testers are agile or only the developers are agile. The whole team needs to be agile. So when we say about agile testing or a agile project, the whole team needs to be agile, and the whole team needs to follow the agile methodologies. So that is where the actual value or the actual ROI of doing agile can be get. But the major problem is like what I have faced in practical scenarios, like rather than doing agile, within agile we do waterfall. So that doesn't make sense.
So that is where we are getting, we are actually implementing or following the agile, waterfall. We're telling outside we are following the agile.
Right. So that doesn't make sense at all. So it's a practical experience what I'm talking about. So as you also said, you also face the same. So, but that should not be the case. So here I'm just showcasing what should be done from a performance testing perspective, by which you can give more ROI, more value in terms of doing performance testing in Agile.
Okay, yeah, got it.
Okay. So we are done with the unit level part. So if we go to the next part, which is the component level performance testing. So now you have tested your particular unit, you have done the unit performance testing. thereafter, there are few integrations and functional testing is carried out. So you have your integrations done. Now you do or create a component level performance scenario. So you have your scenarios already available. So you do a component level performance testing and you see whether a performance issue is identified or not. So here the main activities or main point would be the scalability and response time for each component would be captured. The performance scripts would be prepared more from an individual component perspective and not from a unit level perspective. Then the performance tests need to be executed for each and every component to see how that particular component is behaving, or to be specific, business specific components, how they are behaving, and optimize that particular component, whether it's a software or a hardware, based on any performance issues or any performance bug which is identified. So this is more at a component level testing what you are doing. Finally, when you clear this particular hurdle, you actually carry out the application load tuning, or whatever we do nowadays, which is the performance or the load testing. So here you actually create the scripts from the end-to-end transactions or the end-to-end flows. So starting from like whatever the business critical transactions you have identified, starting from say login to our application and navigating and doing whatever, and then logging out of the application, all those scenarios, all the actual performance testing essence is where is at the application level you actually see or you test that particular code. So you create the scenarios or you create the performance scripts for the flows what you have identified. So it is an end-to-end flow here, not at a component or a individual level. And the application is tested for normal load and maximum load depending upon the requirement. So whatever type of test you want to carry out, stress, load, performance, whatever. And very important here is you capture the server and the client metrics. So the CPU, disk, memory, utilizations, how they are performing under load, what if at all there are any issues or not, and then you try to optimize the whole application. So if you see here in all the three the three approaches what have been mentioned here, starting from a unit level, that is at a very small level, you do the performance testing. You see whether there is a performance bottleneck or a performance issue at a unit level, that is at my code level or at my method level. If that is a problem, then you actually integrate that particular method or code with your component. You do a performance testing at a component level as well to see whether my component is behaving properly or not. And finally, when everything passes, you actually do a performance testing at an end-to-end application level. So where your end-to-end application navigation, your end-to-end application flow is getting captured. And most importantly, you carry out a server and a client metrics. You capture those particular data here. So you can see here, like when you carry out an end-to-end application load tuning or load testing here, the UAT testing is already done. So you have a functional bug-free environment already available with you. So the actual performance test or the actual like the load, stress, or different types of performance tests should be done during this particular phase. Okay.
Hello Sudeep, Ashish here.
Yeah, Ashish.
Sudeep, I am having one question regarding that unit level testing. So yeah, if you do perform testing of any particular code, so are you going to cover the DB and also means shall you cover the code level performance tuning and DB level performance tuning in unit level testing?
It depends upon the method. If that particular method has high amount of database interaction, then ideally you should. And if that particular method or if that particular call is only at a system level, then you can remove it. But ideally, if at all you have a heavy read or write into the database, then ideally you should take the database also into consideration. But surely, like when you will be doing a unit level performance testing, you will be you will be giving some normal load to that particular method, so which will eventually give load to the database. So you will see how my data, because like once, and when that same method is getting called say 100 times, so there is a big huge difference on how my application or how that piece of code can behave.
Okay, okay. And in this unit level testing, we can exclude the infrastructure tuning and server level tuning.
Right. Yeah, you can, because your more focus is at a code level, and whatever the new code has been written, is it giving a good performance or not? So you're trying at a very smaller level, that is at a unit code level, to see how it is behaving, how it is performing, and then taking it up size by size.
Okay. Yeah. Thank you, Sudeep.
Thank you. Okay. Now some benefits for doing this particular method. So say for example code tuning, you are doing a unit level tuning very early in the phase. So there is no need of code optimization at a later point of testing life cycle. So this is a very big advantage which agile performance testing actually gives us. Application rejection is highly reduced if you see, because of say any hard-coded values in the code, any database locking, or any memory leaks. Very important criteria. Like as in waterfall, you cannot do in waterfall, or you cannot detect any performance issues or any performance bottlenecks in waterfall at an earlier phase, at an earlier stage. But in agile, you are actually reducing the effort for duration for performance tuning and retesting, because you're doing it iteratively and you're doing it every time. So whether it is at a unit level, whether it's at a component level, or whether it is at a end-to-end application level, when your existing code itself is performing well, then the above systems or my above components are bound to perform well. But surely how they will actually perform under load, under actual circumstances, that is where the application level performance testing is done, and that is what we do at the last phase. Finally, the release dates, like iterative testing leads to a constant awareness of the application performance, and therefore more confidence is given in terms of meeting the release dates. And that is where, like if you see, I'm again stressing more on the continuous integration part. So the continuous integration for the performance testing tools with different CI servers, that is a very important criteria that needs to be done explicitly for all the code check-ins that have been made. So then only you can actually come to know how my particular build is behaving in terms of performance, both at a unit level, both at a component level, and finally at an application level as well, that if my build gets changed, how my application performance is going up or down. So that needs to be checked as well. So that is why I'm stressing again on the continuous integration part also. Finally, since Agile is an iterative model, so you have less number of performance bugs in the subsequent phases or in the subsequent sprints. And most importantly, your performance scripts are reused. So almost you can reuse them 60% of the times, and this can eventually lead to reduction of your efforts for the performance testing cycle. I understand that during the first initial stages, it will be really difficult to actually implement it, but once that particular application has higher number of sprints or higher number of deployments into production due to Agile, then the ROI can be actually seen of where this particular approach or this particular methods can be. Finally, like a summary that we want to understand, like by Agile performance testing, we are not doing some more performance testing or any quicker performance testing, but it's a continuous focus that we are trying to keep on the application, and that too from a performance perspective. So whether it's at a unit level, component level, or an end-to-end application level, we want to keep a focus on the whole application itself. So a continuous focus is what we are trying to keep here. Again, performance is a part of everyone's job. It's not only a performance tester's job to make the performance testing happen or do the performance testing. It's everyone's job, starting from developers, solution architects, testers, everyone. And finally, the success for this particular method, as I've said earlier, requires a shift not only from people, but most importantly process, because Agile and Waterfall, they don't match at all. And the testing team is Agile and the development team is Agile. The whole team as a whole, the whole team needs to be Agile in terms of following the practices and doing a better collaboration. Finally, like I've added some resources in terms of what can be done for unit level performance testing. Like this is we have heard it, like most of us have heard it from the first time. So there are a few frameworks, if you can see, JUnit, Perf, PUnit. These are nothing but unit level performance testing frameworks which can be used for doing unit level performance testing. Most of you must have used JUnit for doing. If not, then JUnit is a very important or a very easy and affordable way to do the unit testing, which is done by the developers. But still, like if you want to know more about these particular unit testing frameworks, unit testing performance frameworks, so the links are provided here. Finally, if you see the third link, that is from Scrum Alliance, that is actually an experimental approach of doing a performance test in Agile. So it's more on a more a detailed way of how you can. And finally, not from a performance perspective, but from an overall testing perspective, catering to manual, automation, performance, other types of testing, security, compatibility, etc., etc. How Agile testing actually forms a part in the whole SDLC. So those sort of information, those sort of link. So in a very short duration of time, I've tried to capture the ways in which Agile performance testing can be done. And just to add, like as Prabhakar also said, like for initial phases, it would be like within the sprints you are doing waterfall, so that does happen. But specifically, if the whole team is Agile and if the whole team is trying to follow the Agile practices properly, then definitely these methods or these approaches, they do give a higher ROI as compared to say a waterfall methodology. So apart from that, I don't have any other points or any other pointers to discuss. So anyone has any questions or any points to share?
Sudeep, Archan here.
Yeah, Archan.
Yeah, actually, I was just a bit confused with that shift left methodology. Can you just explain?
Yeah, I can go there. Right.
Actually, in the current project which I have in DTRA, my plan is suppose performance testing should be done for next sprint. I am planning this in this sprint. So that's how it is going currently.
Okay. So, but like the ultimate goal of showing this is that we should not do late performance testing for a particular sprint. So even if you see the waterfall model, if I go to the waterfall part, this is the waterfall model, and if you see here, performance testing comes after all the, say, system integration testing, the UAT testing is done, and then there is a small scope for performance testing which is there or which needs to be carried out before production deployment. So what we are trying or what Agile is trying to focus is, rather than doing performance testing at a later phase of time, you shift towards left, that is towards planning, towards designing, and towards building an application or writing a code which in itself performs better or gives a higher performance. So you need to perform performance testing from a planning phase. You need to perform performance testing at a design phase. How you design the particular application, how you create an architecture which will actually give you high performing application. So that those scenarios need to be taken up. And more importantly, after you design your architecture, how importantly or how you write your application code so as to give a high performance. So by that I mean to shift left in the cycle. Does it answer your question?
Can you give any real-time example for this? Theoretically, I cannot get it.
Real-time example would be, say for example, if you are developing a particular application, then how you can actually create an architecture which will actually give you optimum performance, because you will be doing the performance testing at a later phase of time. So how you can actually capture, say for example, architecture. Okay, I'll give a real-time example in terms of the applications that have been tested here itself in Ericsson. There is an application called as Merlin. You all must have heard of. You all must have done your self-assessments there. So the requirement for Merlin was to sustain a 2000 user concurrency. So how do you architect or how do you create an architecture which can sustain 2000 user concurrency? That is where the question is, and that is where the shift left actually comes into the picture. So basically, when you are actually designing that particular architecture, how optimally, how much optimized or how much better you can create that particular architecture, how much distributed you can create that particular architecture so that it can sustain the 2000 user concurrency. Does it answer?
Okay, in that case, performance testing point of view, what can be the input? Because most of the cases, what I faced so far, that the architecture team, they dimension it by their technical knowledges.
Right. So in those meetings, in those scenarios, the performance testing or the performance tester also needs to be there, needs to be made available. That how you can actually create a performance, a highly performing architecture which can sustain a certain amount of user concurrency. So that is where we are taking it to the next level, not only from performance testing but more into performance engineering. That how you will actually create a high level of, or how you will create an architecture that can sustain certain users. So that is what needs to be seen there.
Okay.
And most importantly, after you create that particular infrastructure, you create that particular scenario, like whether the code that is being written, whether the code itself is performing well or not. Okay. Again, like just to add a particular point to your case, like for the same example, like Merlin. Like for Merlin, the infrastructure that was initially given was to have all the servers located in a centralized location in Bangalore. But Merlin is a global CAT tool or a global tool that will be used across different or will have users from different locations. When different users will access this particular application from different locations, obviously there will be a high amount of user network latency. So why keep the servers at a single location and why not geographically distribute it? So this was one of the key takeaways that came up while designing that particular infrastructure. So few servers are located in Australia, few servers are located in US, few servers are located here in India, and most of the servers are in Sweden. If that initial discussion would not have happened, all the servers would have been there here in India itself.
Got it.
Yep.
Hi Sudeep, Puneet here.
Yeah, Puneet.
Yeah, I just want to understand about the load profile. For example, in every sprint, new functionality or user stories will be added, right?
Right.
So in that case, will the concurrency or the load will be increased? For example, in sprint 1 you had around, if you have 10 user stories and you have 100 users, so will the requirement be like this, like for the next 3 new user stories you will be adding 50 concurrent users, or it will be, I mean, how ideally the requirement will be there for the load profile requirements in Agile?
It depends actually. It depends upon the requirement. So I cannot explicitly say like this is how it happens. But if you see the particular slide, like I've given few examples on how it actually shows. So say for example, like a banking transaction could have a high amount of user concurrency, or any other module. Say viewing a balance, a bank balance can have a lesser number of user concurrency. So it actually depends upon what the user story is talking about and what is the impact of that user story in application performance.
Okay.
Like just to give again a real-time example on how it works, Merlin. Like Merlin is a tool, like as I said. So for Merlin, the basic profile actually talks about, as a practitioner, I'll be doing just my self-assessment. I won't be doing anything else there. Or I'll be adding few competencies and I'll add few competencies, will do some self-assessment and will never use the tool. So for Merlin, the higher usage would be doing the self-assessment. So at that point of time, how at a user concurrency level, how say a set number of users are doing self-assessment for that particular module, how that particular module behaves, that is how my user story will talk about. So self-assessment will have a certain different amount of users. Any other module, say in Merlin, will have any other set of users. So it actually again boils down to what your user story is actually talking about and how critical is this user story for your application performance.
Okay. Thanks, Sudeep.
Okay.
Sudeep, Vaibhav here.
Yeah, Vaibhav.
You were mentioning like as for performance tester, we should be more kind of mentors to the agile team.
Right.
So like we are following different approach for doing unit testing, then going to component and then going for the integration level test, application level testing.
Right.
So the role of as of now we see that we should be guiding them to do this code component and unit level testing, or should we create scripts for them and they're going to do it?
It depends upon, like it completely depends upon project to project. So because I'm sure like none of the developers would be aware of the unit testing performance frameworks because hardly no one uses them.
Right.
So it completely depends upon project to project requirements. So in some projects, developers they themselves do, because again, like unit testing is a developer's activity. So ideally they should do it. But if at all they are not aware of, and if we want to create a performance culture in the organization, in the COE, in the project itself, then it's better that we start ourselves so that this can be incorporated. These points, these new frameworks can be incorporated in the performance testing, and from there it can be taken up, because you're starting at a very small part, that is at a unit level. So eventually going down the sprints, say after 4 or 5 sprints, you will start getting value for doing those unit level performance tests.
Right.
And again, like when you actually capture or when you actually integrate it with a CI tool, so build 1 was highly unstable and say build 50 is very stable. So you see the whole versioning or the whole history that will actually help out in understanding where it actually failed, because of which what it failed, and why the SLAs were not met.
Yeah. So like I have a linked question to this, like so for this, are we going to, we are setting up a separate environment for our performance testing? Or are we going to use the same environment on which the developers are doing the coding?
Ideally, the same environment, because there we are not actually like we are not more we are not actually looking for the end-to-end flow. We are actually more concerned about the method level or the function level call. So whether that method or that function actually takes in the required performance SLAs or not, that is what needs to be seen. Because obviously this is agile, and they won't be deploying that piece of method to say a test environment unless and until that particular method or that particular flow itself is completed. So in the environment itself where they have created it, it needs to be tested, and that is why I'm saying like unit testing or unit performance testing ideally should be a developer's activity.
Yeah. So let's say we are doing the application level testing, and we are seeing several builds coming in every 2 weeks. And so as for now, I think like it's going to increase our work rather than to be reused. We might need they will be making small changes to the in every sprint to their code base, and we might need to rescript our scripts. So how can we say that it's going to increase the reuse? As of now, I can see it will create our task more tedious because we might need to do rescripting every 2 or 3 builds. Maybe that's one script we can use for 2 sprints, and after that we make some changes to optimize the application.
No, you will not script. You will not change the whole script. You will only change the module or the snippet which has been changed. Why you will change the whole code? You will not change that. The initial how does a performance testing tool work? It works on a request and response.
Right.
If my request and response are perfectly fine for the initial pieces of code, and for say a particular transaction it is failing, so for that particular transaction I'll make the changes. I'll not make changes for the whole. I'll not do rescripting.
No, but the components which you are initially testing, they might be getting improvised in as the agile life cycle is going to increase, right?
Yeah, but you need to change, or you need to modify them. You need not rescript them. That's what I'm saying.
Yeah, so like if you are modifying those scripts, so it's kind of rework rather than reuse.
Yeah, but still from a as is reuse, the effort would be comparatively very less.
Okay, I don't fully agree to that point, but yeah, let's go with that.
Not only, sorry, Prabhakar here. So not only with the scripting of work, again, the application will be mostly unstable, and maybe need to repeat the executions number of rounds whenever they are making
That is why we are talking about more of a continuous integration here, because that stability or instability of the application, the CI information will actually give you.
So usually in waterfall we keep a entry criteria, exit criteria for our test rounds.
Right.
So we tell them that it should be functionally tested and stable. But
Right.
here we may not be able to fix to it.
Yeah, that is why you're doing agile, because in agile you don't expect everything to be foolproof. That is why you're giving a 2 week sprint. So every time, like just to let everyone know why we are giving a 2 week sprint, so as to have a feedback, iterative feedback very soon into the life cycle. So it's not that whatever I deploy in the production, whatever my application, that will be 100% foolproof. No, it won't be. So it is iteratively by small and small changes. That is what you are trying to make or create an application which is high performing. So you need to start somewhere. So you need to start basically at the unit level, then go to the component level, and then you do the end-to-end performance testing.
Okay. So I mean, it has advantages as well as some overhead compared to waterfall. That's what.
Waterfall hardly is being used by or hardly will be used in the coming years. It will be all agile. So it's better, like we all try to understand how agile should work, how we can add value to performance testing in agile, and what needs to be done for agile performance testing. So this information, these details actually talk about those points only. So again, like if I say here, it's not that I'm doing a rework or I'm doing more work. I'm keeping a continuous focus on application performance, starting from the application code itself at a unit level. And that is what Agile talks about.
Yeah.
Okay.
Hello. Yeah. Yeah. Okay. So.
Yep. Any other questions? Any other points?
Sudeep, Archan here. One more question from my side. That is,
Hello,
what
Sudeep,
is the
Ashish here.
benefits of using CI tools rather than using, say, Performance Center? If I can repetitively use Performance Center for scheduling the load tests and all.
Right. Archana, again, like Performance Center can actually schedule your particular tests. You can actually see the raw results. No worries on that. But your CI tool will actually give you the result, and how how your application based on your application build, how your performance was changing. So you can create SLAs in the CI tool itself, whether my response time should be less than 5 seconds, 8 seconds, whatever. And whether my SLA has passed or not, that you can actually see more easily using a CI tool. So we should, like, ideally everyone should use a CI tool in their performance testing lifecycle. Definitely, Performance Center is used, but you can actually integrate Performance Center with say Jenkins, so that can be done.
Hello, Sudeep, Ashish here. I'm having one question.
Yeah.
Sudeep, if we are doing any code level changes and we deploy the new code, so we have to do some modification in our script, and we can create our built-in continuous integration tool, and we can do the execution. But if there is a complete environment change, as you know that we are developing our script in dev environment or Q environment, and when we will get the NF environment, we'll do the execution. Or if there will be any DB level changes, some index restructure will happen, or some infrastructure level of changes, then how we can associate this thing with continuous integration?
Ashish, I did not get your question. Can you repeat it?
Yeah, sure. Look, in continuous integration, if there will be a code change, means we are doing some minor functional change, we can do our script modification, means our non-functional script modification, and we can do the execution with new build. Means we can create the build in XML and then we can do the execution, so that we can compare the previous build and the current build. Right. So if we are doing any infrastructure level of change, means we develop our code in Q environment, and right now we are doing the execution in non-functional environment. So we cannot compare
you cannot compare. You cannot.
So in that case, we have to first do the baseline test in with CI integration tool. Right.
Yes, correct. Then in that particular non-functional environment, you need to carry out the testing.
Okay. So applicable to all the things, do some infrastructure level of changes or DB level of changes, the baseline test with continuous integration tool, then on top of that we can create our new builds. Right. Yeah, that was more from a agile perspective. So this scenario ideally will not come there, because you already have a system which is which you are delivering each and every sprint. You have an application already or a particular build already available. So you expect least number of changes to that particular component or to that particular module. You expect new modules to come in, but to that particular module you are expecting least number of changes. Okay, so that is where what I said, like initially in the sprint 1 or sprint 2 phases, it will be highly difficult or highly it does feel really troublesome to incorporate performance in Agile here. But once it goes or once few sprints pass, after certain sprints, like after sprint 5 or 6, actually you try to get the benefits of doing Agile performance. Yes, I got it. Thank you.
Okay. Any more questions? I think we have overshot on time. Uh, Vaibhav, it's back to you.
Thanks, Sudeep, for the session. If you can share the presentation, that will be great.
Yeah, I'll surely do that. Yeah.
So I think let's close the call. It's already 3. So if any doubts, we can contact Sudeep.
Yep. Okay. Thank you. Thanks, everyone. Thanks. Bye.
Thanks, Sudeep.
Thanks, Sudeep.